Following on from the previous video of me trying to give you a summary of what we've done so far, if you integrate from 0 to 1, so if you try and find the area from 0 to 1 of 1 over the square root of x, it will give you 2. So this area here is 2. But then if you try and find the area from 1 all the way to infinity, so that's this area here, all the way to infinity. So if you're trying to find out the area from 1 all the way to infinity, so if you're trying to find the area from 1 all the way to infinity, then integrate this. That will then give you this, and then put b into here. That will then give you this, and then put 1 into here. That will then give you this. Now, if you look at this here, if you look at the square root of b, it will look like this. Now, when you allow b to head towards infinity, square root of b will just get larger and larger and larger. So what it's saying is that this thing here, as b heads towards infinity, this thing here will just get larger and larger and larger. So what that means is, if you're trying to integrate from 1 all the way to infinity, so if you're trying to find out this area from 1 to infinity, as b heads towards infinity, this area here is just going to get larger and larger and larger and larger. It doesn't converge, it will diverge. So from 0 to 1, this area here will converge to 2. But then if you try and integrate from 1 all the way to infinity, this area here will diverge. Okay, and we've seen that. So here, something else that we've already seen as well. If you're trying to find the area if you're trying to find out the area from 0 to 1, if you're trying to find out the area from 0 to 1 of 1 over x to the power of p, if p here is strictly less than 1, then the area from 0 to 1, will converge to this thing here if p is strictly less than 1. So for example, if you look at this, 1 over the square root of x, let's write 1 over the square root of x as 1 over x to the power of a half. This is your p here. P here in this case is half. So if in this case p here is a half. Half is less than 1. So the area from 0 to 1, so that's this area here. From 0 to 1, this area here will actually converge. But then if you look at, let's say, if you look at a case where p is greater or equal to 1, let's just look at this case here. Here p is 2. Here p is 2. 2 here is greater than 1. So if you're trying to find the area from 0 to 1, if you're trying to find out the area from 0 to 1 of this thing here, so that's this area here, from 0 to 1, this area here will actually diverge. So if p is equal to or greater than 1, the area from 0 to 1 will diverge. But in the case of p being strictly less than 1, that's this case here, is strictly less than 1, then this area here from 0 to 1, then this area here will actually converge to this. P equal to or greater than 1, it will the area from 0 to 1, will actually diverge, and we've seen this in the past. So here also the other way, going the other way from 1 to infinity. So going the other way from 1 to infinity. So going the other way from 1 to infinity. If you look at the red line. If you look at the red line, 1 over the square root of x, if you're trying to work out the area from 1 to infinity, from 1 all the way to infinity of the red line, which is 1 over the square root of x. So if you're trying to find out this area here from 1 to infinity, then the whole thing here will diverge, meaning the area will just get larger and larger and larger. If you're trying to integrate from 1 to infinity, the area will get larger and larger. And then if you look at 1 to infinity of 1 over x, so that's this blue line here, that's this blue line here. 1 over x is this blue line here. If you're trying to find the area from 1 to infinity, from 1 to infinity of the blue line here, so that's this area here. This area here will just get larger and larger and larger. It will diverge. But if you look at 1 over x squared, that's this green line here. Now 1 over x squared, that's this green line here. If you look at the area, from 1 to infinity of the green line, if you look at the area from 1 to infinity of the green line, that's this area here. This area here will actually converge. Okay, so if you can, try to commit the following to memory. If you try and find the area, let's say from 1 to infinity of 1 over x squared dx, then this whole area here will converge. But then if you try and do the same for over here, let's say from 1 to infinity of 1 over the square root of x dx here, this area here will diverge. So this thing here will diverge. This thing here will also diverge, but then this thing here will converge. So if you're trying to find from 1 to infinity dx here, this thing here will converge. But then going the other way, if you're trying to do this, let's say from 0 to 1 dx here, this area here will converge. This area here will converge. But then if you try and do the same for this, from 0 to 1 of 1 over x dx here, this thing here will diverge. So this will diverge, this will diverge, this will converge. Up here, this will diverge, this will diverge, this will converge. Okay, try to commit this to memory. Okay, so this will converge and this will converge. Okay.